Okay, guys, so this is Unit 1.3, Absolute Value Inequalities. This is our third section of Unit 1. And the objective today is to write and be able to solve absolute value inequalities and graph those solutions on a number line. So the first possibility is a less than. So suppose you're asked to graph the solution to the absolute value of x is less than 3. The solution is going to be all the points that are less than 3 units away from 0. So look at this number line. So what are all the points that are less than 3 units away from 0? So you say 1, 2, 3, and you say 1, 2, 3. And all the points that are less than 3 units away from 0 are in this shaded area from here to here. Those are all less than 3 units away from 0. So taking this picture and translating it into algebraic symbols, you find that the solution is x is greater than -3 and x is less than +3. So that's how you would write that. The other case is greater than. So if we have absolute value inequalities that are greater than, then what we need to do is go back to the number line and look at the absolute value of x is greater than 2, for example. So we go 2 away from 0, and we are going to shade in each direction. So x is more than 2 away in each direction. That is our greater than. X is greater, the absolute value of x is greater than 2. If we take this into symbols, that would be x is less than -2, or x is greater than +2. Okay? So again, we write this as two inequalities. Now, let's go to example 1. We want to solve and graph the solution on a number line of the absolute value of 2x plus 3 is less than 6. So first, I'm going to write this. The absolute value of 2x plus 3 is less than 6. And when I have the absolute value isolated by itself, then I can split it up into two inequalities. So my first inequality will be 2x plus 3 is less than 6. And my second inequality will be 2x plus 3 is greater than -6. And I'm going to solve both of these. Notice all I changed was the sign from less than to greater than and the number from 6 to -6. So in the first equation, or the first inequality, I write it exactly as it is. In the second one, I change the sign and the number. So I'm going to subtract 3. So 2x is less than 3, and then I'm going to divide by 2. So x is less than 3 halves. Over here, I'm going to subtract 3. So 2x is greater than -9. Now I'm going to divide by 2. So x is greater than -9 halves. So x is less than 3 halves. So I'm going to go to 3 halves, make an open circle. X is greater than -9 halves. So I'm going to go to -1, -2, -3, -4, -5. -9 halves would be -4.5. So I'm going to make an open circle there. It's greater than -9 halves. So that means it's to the right of that. But it's less than 3 halves. So that means it's to the left of this. So I'm going to shade in the middle. And again, you can write your numbers on the number line so that you know where exactly you're at. Okay? So that is example number 1. Notice I shaded in between those two. They are open circles because they were less than and greater than, and they also did not have the equal to. So that made it not a closed circle. So let's go to example 2. Solve and graph this solution. So the absolute value of 2x minus 3 is greater than or equal to 5. So I'm going to split these up. So I'm going to have 2x minus 3 is greater than or equal to 5. I'm also going to have 2x minus 3 is less than or equal to negative 5. So these are my two. And I'm going to work through this. I'm going to add 3. So 2x is greater than or equal to 8. And then I'm going to divide by 2. So x is greater than or equal to 4. Over here, I'm going to add 3. So 2x is less than or equal to negative 2. And then I'm going to divide by 2. X is less than or equal to negative 1. So the less than or equal to's and greater than or equal to's are going to be closed circles. So I'm going to put one at 4. And I'm going to put one at negative 1. So it's less than or equal to negative 1. So that means I'm going to shade to the left of negative 1 all the way over here. And I'll make an arrow pointing. And it's greater than or equal to 4. So that means I'm going to shade all the way here to the right. And I'll make an arrow pointing that way as well. All right, so that is your absolute value graph there. So if you notice, these are shaded on the outside. These are shaded in between. It depends on your answer. So you look, your bigger number is 4, and it's greater than 4. So that means to the right of 4. Your smaller number is negative 1. It's to the left of negative 1. So that means it's less than, so to the left. Here, your bigger number was 3 halves, 1.5. So we went to the left of our bigger number. Our smaller number was negative 4.5. So we went to the right of it. So that's why we were shaded in the middle. Now, there are a couple special possibilities down here. So if you look, these are things that could happen. Special possibility number 1. You could get the absolute value is less than a negative. In this case, absolute value, no matter what we put in, has to be a positive number. So it can't be less than a negative. No matter what number you put in for x, when you take the absolute value of it, it gives you a positive. So it can't be, the absolute value cannot be less than a negative. So our solution is clearly no solution. So if you've ever isolated absolute value by itself and you get a negative, it less than a negative, there is no solution. Now, if the absolute value is greater than a negative, in this case, any number I put in here will give me a positive. So if I put in negative 20, well, negative 20 minus 2 is negative 22. The absolute value of negative 22 is positive 22, and that's greater than negative 3. Doesn't matter what number I put in for x, it's going to be greater than negative 3 when I take the absolute value of it. So my solution is all real numbers. So it would be everything. Now, if my solution's all real numbers, how would I shade that on the number line? Well, I would just shade all the way across in both directions, all the way to the left and all the way to the right. So that's how I would shade all real numbers. And there's the first page of our notes. So let's go to the second page of our notes and look at these three absolute value equations or inequalities. So the first one, the absolute value of negative 9 plus p and then plus 5 is less than 24. I'm going to subtract 5 first because I want to isolate absolute value by itself. So I've subtracted 5. 24 minus 5 gives me 19. So I have the absolute value of negative 9 plus p is less than 19. So I'm going to write negative 9 plus p is less than 19. And I'm going to write negative 9 plus p is greater than negative 19. So again, remember, I flipped the sign and the number. And that's how I write my two inequalities. I'm going to add 9. So p is less than 19 plus 9 is 28. Over here, I'm going to add 9. P is greater than negative 19 plus 9 is negative 10. So P is less than 28 and greater than negative 10. Now let's go up by, we'll go up by 4 at a time. 4, 8, 12, 16, 20, 24, 28. And let's say 0, negative 4, negative 8, negative 12, negative 16, and so on. So P is greater than negative 10, so negative 10 would be about right here. It's greater than, so that's an open circle. And P is less than 28, that would be all the way over here. Again, an open circle. It's less than 28, so we shade to the left of 28, and it's greater than negative 10, so we shade to the right of negative 10, and they will meet in the middle. So there is your shading. All right, let's go to B. First step, we want to isolate absolute value. We want to get it by itself, so we want to subtract 2. So the absolute value of 7 minus x is less than or equal to 10, and then we want to split it up. So 7 minus x is less than or equal to 10, and 7 minus x is greater than or equal to negative 10. Those are our two inequalities. We're going to subtract 7. So negative x is less than or equal to 3. We're going to subtract 7 here. So negative x is greater than or equal to negative 17. Now, we have a negative x. That's like a negative 1. So if you divide by negative 1, remember, it's going to flip your sign. So if I divide by negative 1, I'll get x is greater than or equal to, and then 3 divided by negative 1 is negative 3. Here, if I divide by negative 1, I'll get x is less than or equal to, and negative 17 divided by negative 1 is positive 17. All right, so x is greater than or equal to negative 3, and x is less than or equal to 17. So let's go up by, let's do 3 at a time. So 3, 6, 9, 12, 15, 18, and let's go negative 3, negative 6, negative 9, and so on. So x is greater than or equal to negative 3. That would be, I would go right here. And sorry, I made this on this graph, so I'll have to show that this goes down here. So greater than or equal to negative 3. So I go to negative 3, make a closed circle. Less than or equal to 17. I go to where 17 would be, make a closed circle. It's to the left of 17 and to the right of negative 3. So I'm shaded in the middle. And there is my graph. Now this third one, I will end up having to use the graph up above. So let's do that. So the absolute value of 5 minus x plus 4 is greater than or equal to 9. So we're going to subtract 4. We get the absolute value of 5 minus x is greater than or equal to 5. And I'm going to write both inequalities. 5 minus x is greater than or equal to 5. And then I'm going to do 5 minus x is less than or equal to negative 5. So I want to subtract 5. So I get negative x is greater than or equal to 0. When I divide by negative 1, it just flips the sign. So x is less than or equal to 0 divided by negative 1 is still 0. Over here, I'm going to subtract 5. Negative x is less than or equal to negative 10. When I divide by negative 1, I'm going to flip the sign. So x is greater than or equal to negative 10 divided by negative 1 is 10. So I get x is less than or equal to 0 and greater than or equal to 10. So greater than or equal to 10, if I put a 10 here, it's closed circle. Greater than or equal to is shaded this way. And then less than or equal to 0, I got a closed circle. And if it's less than or equal to, it's shaded all the way to the left. So there's my graph. Okay, let's go to our tolerance word problems at the bottom. There is a formula for the tolerance. It is the absolute value of the actual, so what it actually is, minus the ideal. The ideal is what we want it to be, is less than or equal to tolerance. The tolerance is how much we will tolerate it being off. It could also be called like the margin of error, how much we're okay with it being off by. So let's read example 3. A carpenter is using a lathe to shape the final leg of a handcrafted table. In order for the leg to fit, it needs to be 150 millimeters wide. That's what we want it to be, right? Allowing for a margin of error of 2.5. That's our tolerance. That's how much we'll tolerate it being off. Write an absolute value inequality that models this relationship and then find the range that the table leg can be. So the actual is x, we don't know what it is right yet, minus our ideal, we want it to be 150, is less than or equal to how much we'll tolerate. That's 2.5. So we're going to split these up. X minus 150 is less than or equal to 2.5. And x minus 150 is greater than or equal to negative 2.5, right? So then we're going to add 150. So let's go and add 150. So x is less than or equal to 152.5. And x is greater than or equal to, if you add 150 to negative 2.5, you get 147.5. So for this leg, we want it to be somewhere between 147.5 and 152.5. And that's the tolerance. Let's go to example 4. A manufacturer allows a maximum of 18.5 ounces of cereal. That's the most. And a minimum of 16.25 ounces of cereal. Write an inequality that demonstrates the constraints. So what's the middle of those? So let's say 18.5 plus 16.25. If we add those together, let's use our calculator. If we add those together, 18.5 and 16.25, we get 34.75. And then if we want to find the middle of that, we divide by 2. 17.375 is actually our middle, kind of our midpoint. So that would be our ideal, right in the middle of those amounts of cereal, right? Because if we allow a maximum of 18.5 and a minimum of 16.25, we want to be somewhere in the middle. So we're going to say x minus, our ideal is 17.375, is less than or equal to, well, how much will we tolerate it being off by? Well, we can find that by saying we can say 17.375 minus 16.25. That's how far off it is that way. And if we did 18.5 minus 17.375, it's how much it would be off in the other direction. So we're allowing it to be off by, or our tolerance, we're allowing to tolerate it being 1.125 away. So x minus the ideal is 17.375 is less than or equal to 1.125. And those are our tolerance problems. Still absolute value, you see. And if we solve these out, we would get 18.5 and 16.25. Okay, so those are absolute value inequalities. Don't overthink it. It's just like absolute value equations. It's just that instead of an equal sign, now we have less than and greater than signs. Okay, so thank you for your time.